Hello, everybody. We are later tonight than usual. But nonetheless, we are going to be getting into representing relationships in a relational database. That's a bit of a confusing phrase, huh? Let's see. Well, let's get into it, shall we?
Now we're going to represent these relationships.
We might do... Depending on what the next one is, we might do 2 tonight. We'll see.
Relationships in the database. And now we're going to represent these relationships in the database. And again, what
database normalization 3NF. There is tons of database theory. Way too much. Way too much to understand without excessive predicate calculus. No, thank you. Do not replicate data. Reference data. Point at data. Use integers for keys and for references. Add a special key column to each table, which we will make references to. Add a special key column. Add a special key column to each table, which we will make references to. By convention, many programmers call this column ID. Okay.
What we're trying to solve here is this notion of database normalization, third normal form. There is so much theory, right? But in this lecture, I'm just going to condense this down to don't replicate string data and use what are called keys. Use integer keys to point at those things. And we're going to use these integers then to point. So we'll assign each row an integer, and then we're going to point from one row to another using those integers. And so we're going to add these special key columns to each of the tables, and help in the database will even give us help managing those. Now,
we want to keep track of which band is the creator of each music track. What album does this song belong to? Which album is this song related to? Music track, what album does the song belong to, which album is the song related to. Which album is the song related to?
And so we still need to keep track of, who is the creator of the album, which album a track belongs to. We've got to create these relationships, and we have to come up with ways to store those relationships. And so the idea is we're going to have a column.
We use integers. Sorry, the yawns. We use integers to reference rows in another table. So 2 would be 2. Artist, album.
Column in a table, which is the key column, and we're going to call this the ID column. And so this is a row. It might have many bits of data here, but in this case, it's just the name of an artist. So this album is going to belong to an artist. And we're going to assign a number inside the database, and so that Led Zeppelin is 1 and AC/DC is 2. And so we have this key. This is called a primary key. And then later, when we want to say that the Who Made Who album really was done by AC/DC, we put the number 2 in. And so the difference here is, instead of saying AC/DC in this record, we just put the number 2 once we've established this number. So we assign keys, and then we have these pointers that point back, and so that's how we model a relationship with these small integer numbers. And so there are three
kinds of keys. Primary key, generally an integer auto increment field. Logical key, what the outside world uses for lookup. And foreign key, generally an integer key pointing to a row in another table. Album ID. Title. Artist ID.
Basic kind of keys that we use. One is the primary key, and that is that little ID column that is just a number. But once we give Led Zeppelin the number 1, Led Zeppelin is the number, has got the key 1 for the rest of that database. The logical key is the text area that we use that you might look up. So the title of the band or the title of the album, that's the logical key. And then the foreign key is one of these keys that is really pointing to the primary key of another row. So that's called a foreign key. And it's
key rules, best practices. Never use your logical key as the primary key. Logical keys can and do change, albeit slowly. Wow. Yawning so much right now. Relationships that are based on matching string fields are less efficient than integers. User ID, login, password, name, email, created at, modified at, login at.
And you might think that you want to use something like an email address as the primary key for a user table or something like that. The logical key should always be separate, and there should always be a primary key, that integer number. Because things like logical keys do change. People do get new email addresses, and if you've got that email address as a foreign key pointing all over the place, it doesn't work out so well. And so that's why you use these small integer numbers that have no meaning outside. So sometimes if you're on a system and you see a URL and you see some number like 422,016, you're like, oh, that turns out to probably be my primary key in their database. So sometimes you can look in a URL and you can see 16. You're like, oh, that URL, and you see some number that have no meaning outside. So sometimes if you're on a system and you see a URL and you see some number like 422,016, you're like, oh, that turns out to probably be my primary key in their database. So sometimes you can look in a URL and you can see these primary keys in the URL, but they don't mean anything outside of that particular system. So like I said, a foreign
key is when a table has a column that contains a key which points to the primary key of another table. When all primary keys are integers, then all foreign keys are integers. This is good. Very good. Artist ID name, album ID, title, artist ID. So that points over here.
Foreign key is a key that is really pointing at a row in a different table. And so we have the album has a primary key for it, but the artist underscore ID points to a row in the artist table, as we will soon see. I have a naming convention, and in my naming convention on this lecture I use ID for the primary key, and then artist underscore ID I use uppercase for the table names, and then artist underscore ID says this is a key, this is just a key that points to the ID key of the artist table. And so that's what I do. So you'll see in all my stuff I'll use that. It's a convention. It's not something SQL forces you to do, but you will find when you go to organizations and work on their databases, these conventions are very important, so I can do something and you can understand the rules in which I created it. Some of these, you'll find this used by some people, you'll find completely different conventions, and that'll be okay. Whatever convention your organization uses, learn that convention. So now we're going to talk about how we put these keys in, and then how we actually make the connections from one row to another row.
A number that points to the primary key of associated row in a different table. Yeah, dude. Look at that. 11% left. Okay, let's just let's get into this, huh?
So now that we know what a primary key, logical key, and foreign key are, we're going to actually start putting these together and creating tables that have these kind of values in them. So when we were done, we drew this picture that was sort of a logical model of how our data would be spread across 4 tables and how those tables are connected. Now we have to take this and we have to map it in a way that leads to the columns and the needed columns in each of our database tables. And so here's what we do. We basically have to take for each and the needed columns in a way that across 4 tables and how those tables are connected. Now we have to take this and we have to map it in a way that leads to the columns and the needed columns in each of our database tables. And so here's what we do. We basically have to take the columns and the needed columns in each of our database tables. And so the needed columns in each of our database tables. And so here's what we do. We basically have to take, and for each of these, when we're going to build a track table, we add a primary key. So we just added an ID field to every one of these things, and that's so we have a place to store the sequence number of this particular row. We have logical keys, we've just marked those are strings, and then we have things like, rating, length, and count, they just kind of go in here. And now we have to model a relationship. So what we do is in the table that the relationship starts from, we put one more column in, and this is the one I will name album ID, and that just is an integer column that's going to record the album ID. So this might be 16, and then 16 goes in here. So there's one of these columns that's a foreign key that points to this, and that's why it's foreign. This is a key that's not in the track table. This is a key in the album table that we're pointing to, and so there's a foreign key. And that's what we have to do, and we just do that over and over and over again, and we quickly convert that picture that was a logical picture to having every table has a primary, and that's what we have to do, and we just do that over and over and over again, and we quickly convert that picture that was a logical picture to having every table has a primary key, and every time we have a starting point, we have a foreign key, and then foreign key. And then we mark these things as logical key, logical key, logical key, and we'll see how we do that. And so that's the picture. Now we have a picture of exactly how we're going to lay these tables out and the fields that we need in these tables. So we're going to do a create table statement.
Should I be doing this too? Oops. Browser.
And I've got this create table statement sitting there.
Where'd you get that?
And so this one's going to be a little bit different.
Let me find this again. Hold on a second. Boom. Got it back. So
we're going to say create table artist, and the ID field is integer, and we're going to add all of this stuff. This is adding to the column to tell it additional stuff. It's a primary key, which means we're going to use it to look up a lot. It's automatically incremented, which means the database is actually going to provide this number for us as we insert records. It's not allowed to be null, it's not allowed to be empty, and it's supposed to be unique. And then it's going to have, the artist is going to have a name column that's just text. So let's do that. We already have our users, and now we're going to do a create table in this SQL, and you can do that. That's okay, that's totally fine. And we have to get this right, and we say away we go. And so now if I take a look at database structure,
So I need just a new database? Can I open the one I did before? There we go. Alright, we'll roll with this. Okay, good.
I've got a users table as well as that users table we were playing with before, and this artist table. Let me go ahead and delete this users table just to say goodbye. Okay, so now we have the artist table, and we take a look, and it's got an ID, and it knows all about this stuff. Okay? So that created the table. We're going to keep doing this. The next thing that we're going to show here is we're going to show the foreign key, right? So artist ID is just an integer. In some database languages like MySQL and Oracle, you would put more stuff here to say this is a foreign key, blah, blah, blah. But in SQLite, we keep it simple and just say that is an integer column, that's a foreign key. The album table has a primary key and a foreign key, and then the title.
Okay.
So we'll go back and we'll grab that text out of my little page. This create table. Go back to execute SQL and then run that. And we'll continue. We'll just, the genre table has an ID on it, and primary key order, you'll just copy and paste these. That whole thing, you do that over and over and over again. So we'll go in here and run that one. And so the last one we're going to do
Track
is the track table. And the only thing that's kind of weird about the track table is it's got two foreign keys, right? It's got an album ID and a genre ID. Once you draw the picture, you just sort of literally translate these things. It's got two foreign keys and a primary key that's pretty much just like all those other primary keys. And, you know, integer counts an integer and length's an integer, all that stuff. And now we've got it. So if we take a look at our database structure, we're going to see that our album, genre, and track are all set up. And these are no columns that we just made with those create statements.
on. Okay. Cool.
Okay? So now let's insert some data. This first insert statement is kind of important to take a look at. So insert into, by the way, the keywords can be upper or lowercase, table name, columns. Now, this table has two columns. It has ID and name, but we told the database that ID was auto increment, so it's going to actually give us the number. It's going to assign the number rather than make us assign. We could make it be 1, 2, 3, but we say, hey, database, you're good at this. Why don't you make it 1, 2, 3? And so there is going to be a record that it adds Led Zeppelin. So let's take a look at that. So we'll insert Led Zeppelin. Oops. Over to SQL. Insert Led Zeppelin and run it. So now if I look at database structure and I look at let's look at browse data and look at the artist database, you will see that I put Led Zeppelin in, but this ID field here was auto incremented. And so it was put there by the database. And now when we do the next insert, which is AC/DC, and we take a look at the data, we'll see that AC/DC is 2. Now, if you're writing this in a program, if you're going to write this in a program, you can get these numbers back from the database in your program, but I'm not writing this in a program, so I have to remember that 1 is Zeppelin and 2 is AC/DC.
Huh.
So I'm going to keep myself a little cheat sheet here to remember that. Because everywhere else in the program that we want to say Led Zeppelin, I got to say 1 now, because the artist ID of 1 means Led Zeppelin in those rows. And so now we're going to go back and we're going to take a look at the next one. And now we're going to put the genre in. If you think about it, we're working from the leaves out, where the track will be the last table that will update, because we have to define the keys for things like rock and metal and Led Zeppelin and all those other things. If you think about it, we're working from the leaves out, where the track will be the last table that will update, because we have to define the keys for things like rock and metal and Led Zeppelin and all those other things. And again, even though the genre table has 2 columns, ID and name, we're only going to specify the name and let the database assign the value. So I'm going to insert both of these and use the semicolon trick.
Cool.
Put a semicolon here and a semicolon there. And run that. And so if I take a look at my browse data and I look at the genre, it's assigned 1 to rock and 2 to metal. I'm going to write that down. 1 rock, 2 metal. I should have done something like rock and country, because I can't even tell the difference between rock and metal, but whatever. That's my musical skill is not what's at issue in this class. So now we're going to put an album in. The album is the first thing that has a foreign key. So if you remember the thing, the album points to artist. And so that means it has a foreign key of artist ID. And so we have to explicitly say this, because the system doesn't know which artist Who Made Who is, but we know that Who Made Who is AC/DC, and that's 2. And so we know to put artist ID in, so we'll say insert into album, title, artist ID, and so we have to know what this 2 number is. And of course, because we have our handy little cheat sheet, we can go over to execute and run that. And I'll put a semicolon there and a semicolon there and run it. And so now we have in the album field, we now have this. And so this was assigned, and so Who Made Who, still have to write down that have this. And so this was assigned, and so Who Made Who, still have to write down that Who Made Who is album 1, and album 2 is Led Zeppelin 4. That makes it even more complex, because the name of the album is Roman numeral 4. I'm sure I can figure that out. Okay, so the next thing that we're going to do is we're going to insert the track record. Now, if you think about the track record, the track has 2 foreign keys, and it's got a lot of stuff. It's got the title, it's got the rating, length, count, but then we got the 2 foreign keys. And so we have to know these numbers. So this 2-1, this 2-1, length, count, but then we got the 2 foreign keys. And so foreign keys, and what we're going to do is we're going to insert the track record. Now, if you think about the track record, the track has 2 foreign keys, and it's got a lot of stuff. It's got the title, it's got the rating, length, count, but then we got the 2 foreign keys. And so we have to know these numbers. So this 2-1, this 2-1, this 1-2 is the genre. We're specifying the genre and the album that this track is from by those numbers. Now, again, we have to use this cheat sheet, but if this was a program, the program would know that 1 was Zeppelin and or 1 was Who Made Who and 2 was Led Zeppelin 4. And so that the programs, this kind of stuff is easier for the program to understand than for us to keep track of and understand. But just so we can get through these few records, and that's why I rely so heavily on my cheat sheet. So here we are with all these numbers. The foreign keys are the tricky part here. Everything else is really quite straightforward. So now I'm going to insert 4 records into my track table. And then run that. Okay, so if I browse data and I look at my track table, this column here, this ID, that's the primary key of the track table, and then here are the 2 foreign keys. Now the interesting thing is now there is replication in these columns, but the numbers are what's being replicated, and that's okay. We went a long time just not to put Led Zeppelin 4 in twice. We could have made this a string, but by making this an integer, it saves tons of storage and makes it super fast. That turns out to be one of the key things that makes databases super fast, is using these integers. So So we take a look at all this stuff. We see that in a sense, by using these little numbers, we are pointing to rows in other tables. The foreign keys are always pointing. They always point to their ID. So these foreign keys are out here. This is the primary key up here. And they always point to a
So this is the track, this is the album, and this is the artist in the album. So album ID, bunch of albums, and then this is the artist, so it tells you who the artist of that album is. Okay.
row in another table. And so we have modeled all those relationships, and you will note here, this is the primary key up here. You see that in a sense, by using these little numbers, fast is using these integers. Super fast. That turns out to be one of the key things that makes databases super fast, is using these integers. So we take a look at all this stuff. We see that in a sense, by using these little numbers, we are pointing to rows in other tables. The foreign keys are always pointing. They always point to their ID. So these foreign keys are out here. This is the primary key up here. And they always point to a row in another table. And so we have modeled all those relationships. And you will notice that in this entire database, the who made who only appears once. The word rock only appears once. The word AC/DC only appears once. What we have is we have duplication in our data, but we are duplicating the relationships, i.e. these little integer numbers, not duplicating the data itself. And in something that's this small, it seems irrelevant. But if you have billions of records or hundreds of millions of records, it's very relevant. Very, very relevant. So the next thing we're going to do is take a look at how you actually reconnect all this stuff together once we've sort of blown it out in these, using these foreign keys and hand constructing all these relationships, now how we bring it back together to show the data to the user.
All right. What does the insert command do in SQL? It defines a new row by listing the fields we want to include, followed by the values we want placed in the new row. Defines a new row by listing the rows we want to include. Defines a new table by listing the rows and fields. I think it's that one. No! Well, it has to be rows, right? Oh! I was so confident. Like, I was acting so confident. It defines a new row. It defines a new row, defines a new column, defines a new table. So insert defines a new row. Yeah, by listing the fields we want to include, followed by the values we want placed in the new row. Hey, look at that. All right. Under 10% left. Oh, man. We'll probably be finishing this in the next week to 2 weeks. We'll see. We will see. But that is going to do it for today. Thank you so much for watching. If you enjoyed this video, please like and subscribe. If you have a prayer request, please feel free to post in the comments below. I'd love to know how I can be praying for you guys. But like I said, that's going to do it for me. Love God, love people, and I'll see you guys soon.